Aloha Algebra 1 students! Welcome back to quarter 4. Today we're starting Unit 8, Polynomials. You'll need your notebook. You'll need a couple of different graphic organizers for today. You'll also need some highlighters, maybe 3 different colors, a pencil, a calculator. And before we get started, let's start filling out the table of contents. And these are the dates that will coincide with the concepts and skills that we're going to be learning in our short polynomials unit. Please make sure that you fill in your page numbers according to your own notebook. And also our notebook check will be next Thursday and our tests will be next Friday. So again, super short unit. Again, it's just going to be 3 different concepts. Today we're going to talk about the characteristics of a polynomial and also adding and subtracting polynomials. And we actually did this back in Unit 2, so this will just be a review. Tuesday and Wednesday of this week will be multiplying polynomials. When you come back on Thursday and Friday, this will be just practice on specifically adding, subtracting, and multiplying polynomials and then putting them into standard form. And multiplying polynomials is super important to both Algebra 1, Geometry, and Algebra 2. And so we're going to spend a couple more days practicing the multiplication of polynomials. Next week, Monday, is Prince Kuhio Day, so it's a holiday. It's a state holiday. When you come back next week, Tuesday, Wednesday, we'll be dividing polynomials. Thursday will be the review with the notebook check, and then again, Friday is going to be our test. So here is our schedule for the next couple weeks. Okay, so the graphic organizer that we're using today is actually a foldable, and when you fold it, this will be the front of the foldable. It'll say characteristics of a polynomial, and then it'll have this on the top and this on the bottom. So first off, the definition of a polynomial is an expression with many terms. The word polynomial here can be broken up into 2 words. Poly, meaning many, nomial, meaning terms. So it's just an expression with many terms. And because they're expressions, we're not really solving the equation. We're just simplifying using addition, subtraction, multiplication, and division. So an expression and not an equation. Next is going to be standard form. So standard form is written, number 1, with the highest exponent first. And then it's going to be in alpha order. So highest exponent and alpha order. Our next vocab word is highest exponent. We call the highest exponent the degree. And when we're identifying a polynomial, we cannot have a negative exponent. That's not an option. So if you see a negative exponent in Algebra 1, we're going to say it's not a polynomial. When you get into Algebra 2, they'll explain to you how to take care of a negative exponent so that we can keep it as a polynomial. But for Algebra 1, we're just going to say we cannot have a negative exponent. This coincides here with our classify chart. And when we say the highest degree, we're meaning the highest exponent in the problem. So if the highest exponent has 0, then we're going to call that a constant. If it's the exponent of 1, it's going to be called a linear degree. If it's an exponent of 2 or the power of 2, a quadratic degree. If it's to the power of 3, we call it a cubic degree. And if it's to the power of 4, we say it's a quartic degree. The leading coefficient is going to be the number in the term of the highest exponent. And so at the very beginning of the school year, we talked a lot about coefficients, and we've been working with coefficients this whole year. So we know a coefficient as just the number that's in front of a variable. A leading coefficient is the number in front of a variable that has the highest exponent. So we're just extending it just a little bit more. Okay, before we move on to our next part, we do need to talk about our number of terms. And I'm actually going to switch it to the next page and use these as our examples. So a number of terms, first off, let's remind us what a term is. A term is one part of the equation. So in number 1, I have one term, and it's just the number 6. In number 3, I have two terms, 7x and positive 1. So they're two different terms. And the terms are separated by an operation. So if you're looking at number 6, there's 4 different terms here. 1, 2, 3, 4. And again, we're separated by a negative here, a negative there, a positive there. And the number of terms tells us what kind of polynomial we're dealing with. So in the case of one term, we call this a monomial. Mono meaning one, nomial meaning term. Binomial, bi means two, like bicycle, 2 wheels. Bilingual, 2 languages. So again, binomial, 2 terms. 2 terms. So here, 7x and 1, this is a binomial. A trinomial is 3 terms, and tri being the prefix that we're focusing on, meaning 3, like tricycle, 3 wheels, triangle, 3 angles, triceratops, 3 horns. So again, T-R-I, this is our prefix, meaning 3 terms or 3 nomials, trinomial. Our last one is when we have an expression of 4 or more terms, we're just going to call it polynomial. Again, poly meaning many, nomial meaning terms. So when we're classifying any type of polynomial, we're going to classify it with 2 things. We're going to identify what is the degree, what is the highest degree there, and also how many terms are in the expression. And so as we look at number 1, we have the number 6. It's just the number 6. There is no variable. Because there's no variable, there's no exponent. We don't have like an x to the power of 1 or an x to the power of 2, or here like we have x to the power of 3 or even x to the power of 4. We don't have that. It's just the number by itself. And remember when we learned about coefficients, we also know that a number by itself is also called a constant. And it's because there is nothing attached to it to change it to something else. If it was like 6x, that's a coefficient because it can be changed. But 6 by itself, there's nothing to change it. So it's constantly 6, always 6, never changing. And so we're going to call this a constant. And the degree is also called constant. Number 2, we have, let's put that down. And what kind of term is it, or what kind of polynomial? We call this a monomial because it's one term. In number 2, we have negative 2x. Here we have an x, but we don't see an exponent. When we do not see an exponent, it really means that it's to the power of 1, and there's an imaginary exponent there. And so this is negative 2x to the power of 1. When I'm looking at degrees, if it's to the power of 1, we call this linear. And so it's a linear degree. And also, how many terms does it have? It has 1 term, so this is monomial. In number 3, we have 7x plus 1. Again, our highest exponent here is the exponent of 1, and it's an imaginary one because this has 0 because there's no variable, but this has the imaginary one. And so we're going to call this linear and binomial because there's 2 terms. Linear because of the x to the power of the 1, and binomial because it's 2 different terms. If I'm looking at number 4, my highest degree is a square, or to the power of 2. Power of 2 is called quadratic. So my highest power is 2. We have quadratic, and this is a total of 3 terms, which is also trinomial. Number 5, the highest power is 3, which makes us cubic. So 4x to the power of 3 is called a cubic degree. And how many terms? 1, 2. So this is binomial. Number 6, we have 2x to the 4th power minus 7x to the 2nd power minus 5x plus 1. Because 4 is our highest power, we call this quartic. It's our quartic degree. And how many terms do we see there? We see 4 different terms. 1, 2, 3, 4. So we're going to call this a polynomial. So how do we classify them? Again, with degrees and with number of terms. Okay, the next thing we're going to talk about is standard form. So when we're talking about standard form, I had given you the directions that number 1, we start with the highest degree first, and then we go in alpha order. Okay, so I'm taking you back to the first page where it says standard form. And again, standard form is that it must be in alpha order, and we're going to start with the highest exponent first. Okay, so here's our examples. We have 7 through 12, and it says rearrange each of the following into standard form. So remember that we want the highest exponent first, but also alpha order. And when we're talking about alpha order, we're meaning alphabetical order from A through Z. So A, B, C, D, E, F, G, H, I, J, K, and so forth. Q, R, S, T, U, V, W, X, Y, and Z. So A to Z. So as I'm looking at number 7, I know that the highest exponent needs to go first. And the highest exponent here is going to be 2x squared. And so 2x squared would go first. 3x would go next because that's a power of 1. And then the number 1 will go last. And if we're looking at the equation in standard form, or the expression in standard form, we can see that it's descending order. This is a power of 2, a power of 1, and then a power of 0. Our constants, or the numbers, they're always going to be last because they're a power of 0. Okay, let's look at number 8. So we're looking for the highest power. In this case, it's 7x cubed. The next power would be x squared. The next power would be negative x. And then our last number would be positive 64. And as we write it down, again, we can see it descending. 3, 2, 1, 0. We can see it in descending order from 3 down to 1. Okay, number 9. We have x cubed, 5x squared, and then negative x, and then 28. Again, same thing. We can see it in descending order. 3, 2, 1, and 0 as an exponent. Okay, for number 10, our highest exponent is negative x cubed, and then I have a positive x and a positive 24. So highest exponent goes first, all the way down to our constant of 24. Okay, let's look at 11 and 12. 11 and 12, we need to do the same thing, but as you can see, we have a double set of variables. We have both A and B. And so remember that we want to go in alpha order. So if I'm looking at my highest exponents of A cubed and negative 2B cubed, we know that A is first, and so we're going to have A go first. And then we'll have negative 2B cubed. Then we'll do our AB, our A squared, B squared, and then our 2AB. Again, in alpha order, first in descending order of exponents, power of 3, power of 3, power of 2, power of 2, power of 1, power of 1. But also in alpha order, A, B, A, B, A, B. And our last example, we have number 12. Again, we're looking at this and saying, what is our highest power, but in alpha order? And we can see that we have two sets of cube roots, cube powers, negative x to the third and 5y to the third power. Again, we're going to write it as x going first because in alpha order, x is before y in the alphabet. So we'll have negative x cubed plus 5y cubed minus 7x squared times y squared plus 13. Okay, and that is standard form. In descending order from highest exponent to lowest exponent, and then also taking into the fact that we have different variables and we're going to go in alpha order. Okay, the last thing we're going to take notes on today is adding and subtracting polynomials. So you actually did this back in Unit 2 in the very beginning of the school year. And let me just quickly remind you that when we are adding or subtracting polynomials, we are just combining like terms together. And we have to combine the same variable with the same exponent. If it does not have the same variable or the same exponent, we look at that as apples and oranges. They're not the same. We cannot combine the two together. So here you can see that we have first the polynomial expression, and then this column where we're going to combine all the like terms together, and then the last column where we will write it in standard form. Eventually, every quadratic equation will be written in standard form. And so this is your time to just practice so that when we get into the next unit, you're used to writing all of your answers in standard form. Okay, let's look at the first example. And this is when you're going to use your highlighters. So pull out your highlighters and let's work this together. I'm looking at 2x squared, and in my mind, I'm trying to think about, is there any other term in my expression that also has x squared? Because they're the same variables with the same exponents, I can combine the two together. And as you can see, we have 2x squared and 3x squared. And so when we're adding them together, we look at the x squared as an individual. And so how many x squareds do we have together? We have a total of 5x squareds. Back in pre-algebra, when you talk to your teachers about it, we always call them like apples and oranges. So we can actually identify it as an object. Like if x squared was an apple, we'd say Eva has 2 apples. She gets 3 more apples. So how many apples total does she have? She has 5x squared. So just make sure that when we have the same variable base with the same exponent, we're just adding them together as an entity. Okay, next, get your second color highlighter. We're going to highlight 4x. And again, I'm looking across the expression to see if there's anything that's like 4x. And we can see that 6x looks just like 4x. And so we can combine the two because they have the same variable with the same exponent of 1. So 4x plus 6x, I will get 10x. Again, that's the same thing as saying Eva has 4 oranges. She adds on 6 more oranges. Now she has a total of 10 oranges. Again, x can be seen as its own entity. Okay, lastly, we have our constants or our numbers 1 and 5. We're going to add them together, and 1 plus 5 is 6. So one thing that I like to do when I'm solving or simplifying a polynomial expression is I like to start at the highest exponent and just combine like terms in that order. That saves you one more step from having to go back in and now rewrite it in standard form. And because I started from the highest and went to the lowest, I can see that this is already in standard form, and then you wouldn't need to rewrite the equation. You would just add in your operators. Because this is positive and positive, we would say 5x squared plus 10x plus 6, and there it is in standard form. Okay, let's go to our second example and pull out a highlighter, a different color, and I'm going to highlight x. Now, go ahead and identify if there are any other terms that also have an x. And as you can see, we do. We have x and 3x. So x plus 3x is a total of 4x. Our other terms are 6 and 5, and we can add those together because they're both constants, and that will be equal to 11. Again, in standard form, it is 4x plus 11. Okay, next is our x cubed plus 2x squared minus 4 plus 3x squared plus 6. So I'm taking my x cubed and I'm looking across to see if there's anything that I can combine it with. In this case, there's not, because there's no other x cubed. So I'm just going to place it by itself. Then I'm moving on to the next one. 2x squared and 3x squared, I know that makes 5x squared. And lastly, our constants, negative 4 plus 6, or 6 minus 4, and we get positive 2. And again, we're going to rewrite it in standard form in descending order, 3, 2, 0, and then also in alpha order. Okay, this next equation. So when we did Unit 2, this was a little confusing for some people. So let me just quickly remind you that when we have a negative in front of parentheses, we cannot just dismiss it. We have to address this negative here. So we're going to take the negative and we're going to distribute it to everything inside of that parentheses that it's attached to. So negative times 2x is negative 2x, as I've written here. Negative times negative 6y is a positive 6y. And so this equation, once we distributed the negative to that parenthesis, I can drop the parentheses and rewrite the equation. So 4x, negative 2y. Again, negative times 2x is negative 2x. And negative times negative 6y is positive 6y. And then from there, I'm going to combine my like terms. 4x minus 2x, I get 2x. And negative 2y plus 6y, I get 4y. And again, that's still alpha order, and they're both to the power of 1. So I'm going to leave it as is. Okay, our last problem on the bottom is x squared plus 6x minus 4 minus x squared plus 6x minus 4. And so here again, we need to make sure that we have a negative outside the parentheses, so we're going to distribute it. Negative times x squared is negative x squared. Negative times 6x is negative 6x. Negative times negative 4 is positive 4. And this is what it'll end up looking like. X squared plus 6x minus 4 minus x squared minus 6x plus 4. So when we're adding these together, x squared minus x squared is 0. 6x minus 6x is 0. Negative 4 plus 4 is 0. And so we'll eventually end up with the answer of 0. Okay, so today's homework is going to be homework 8.1. And this is due on Friday. Also for number 20, when students were working it out in class, they did have questions on number 20. And so I took 20 and I just wrote it out here for you. This is what it should look like after you write it out in symbolism. So in words, what it says is subtract negative a squared minus 5ab plus 3b squared from 3a squared minus 2ab plus 3b squared. And when you write it out in symbols or letters and numbers, this is what it will look like. Again, come back in on Wednesday. If you have any questions, come with your questions so that we can talk about this before we move on to multiplication of polynomials. Okay, have a great day. Thanks.